This is the second video in the series, technically the third if you include a previous video where I taught you how to install Vivado version 2022.2 while making sure that it retains a small file size. The previous video to this one was an introduction to comparators, which is where we want a 1-bit comparator shown here on this page right here that is going to compare 1-bit X, a 1-bit Y, and say whether that's greater than or less than the number. The ultimate design that we're looking for, the final design, was going to use 3 comparators to compare a 3-bit X to a 3-bit Y. If you haven't watched the previous video, you'll want to do that now so that you understand where this design is going. This is the K-map, the truth table that we developed to make it work. Here are the K-maps and the expressions. So let's go ahead and introduce Vivado and how we design combinational logic. Here is what a project looks like. When we first launch Vivado, we will do File, Project, New Project. You will hit Next. You will give it a useful name and make sure that you know where you're saving it to. You will hit Next. You will choose RTL project. That's real-time logic. You will hit Next. You will choose a particular target. What hardware are we specifically designing this for? We are choosing to design for the Basis 3 board. You may either install a specific board to this, the Basis 3, as I have done, if you are doing this on your own computer and not a lab computer, or you can just specifically choose the FPGA that the Basis 3 uses. That is the XC7A35TCPG 236-1. You can find that by looking up the Basis 3 datasheet. Then you will hit Finish. I've already done this and created a project because it takes a small amount of time. So this is what will pop up. The first thing that you want to check is that you did in fact create a VHDL project. You can do that in the project summary window, looking for target language VHDL. If you did not choose VHDL, you will instead go to Settings, go to Target Language under General, and choose the drop-down to VHDL and hit OK. Then you will create an Add Sources button. Specifically, we want to create a design source. You will hit the plus button. There are 3 types of design sources that you can add. Constraints. Constraints are the file that tells your final design how it is actually connected to the hardware. What physical pins are your ports connected to? Design files are files that contribute to that final design, and simulation sources are sources that we use to test our design files. We're going to start with a design source, hit Next, and create file. You will give it a name, something like comparator, which I have already done. So I'm going to have to comparator underscore 1-bit, for example, and maybe version 2 if I was going to be doing this, and hit OK. We do not want to put the 1B, is signifying the 1-bit at the beginning, because Vivado will throw an error that is very difficult to debug if you start a file name with a value. You will hit OK. You could, at this point, create another file, but I'm just going to hit Finish. This allows me to specify the ports. I'm not going to do that here. I'm going to do that after I have created the file. I'm going to hit OK and hit Yes. This will create a design file up here in Design Sources. That's right here, the 1BV2. That's what I created. And you will notice that it creates a link here in the simulation sources, because of course we want to be able to simulate our design. So it is both a design source and a simulation source. If you don't want a file part of your design, so I've already created something called comparator 1B. I like that file than version 2, so I'm going to right click on that, and I'm going to remove that file from my project. I may optionally also delete that from the file directory, which I'm going to go ahead and do. It will add a question mark and then update, and it is now gone. So what I'm left with is a comparator 1B that I created in the same way as the 1BV2 that I showed you previously. This icon next to it with the green rectangle with the 2 gray rectangles underneath means that currently this is set as my top level design. This is not supposed to be my top level, but we'll fix that at a later time. Double click on it and it will open. It populates this design file with a whole bunch of text that we don't really need to worry about at this moment in time. What we want to focus on first is the entity. The entity is a description of what the outside world will see and inform it, how shall we connect to this design file. So let's go back and look at this. It's going to create this block for us, specifically these ports that I want to create. So in those ports, the first thing I need to do is uncomment it. I'm going to have an X and a Y that are inputs of type standard logic. Standard logic is like a bit, however, it has other representations that it can do, such as U for undefined if it doesn't know what the value is. I'm going to create another line that is going to be the GI and LI inputs. Give it a direction. So colon direction is an input. It is also standard logic. Now, I'd like to point out that I could have done the GI and LI inputs separated by commas on the previous row with the X and Y. However, I like to group like inputs on individual lines because it improves code readability. Next, I need my outputs, which are GT and LT. So GT, LT, colon, out, because that's their direction, and they are also standard logic types. This line does not have a semicolon at the end because this line is terminated by the parentheses and that end line semicolon. Notice that if I put my cursor right before the open parentheses, it will highlight the parentheses that is closed to that one, so you can check that your parentheses are in the right place. The next portion that we need to be concerned about is the architecture. The architecture is a description of what it's doing or how things are connected. The two main types of architecture that we'll have is either behavioral or structural. Let's first focus on behavioral. Now, I would like to note at this time that this location right here, line 41, where my mouse cursor currently is what is called the architectural header. This will be used later in other design files. We do not use it here, but this is an important location where we create new elements that we can use in our design. I don't need that. So after the begin is where I make the behavioral or structural design. In this case, I would like to describe how a comparator, specifically a 1-bit comparator, behaves. I'm going to do that simply by adopting these equations. I don't think adopting is the right word, but stick with it. So it is less than is Li or GI, not GI and not X and Y. So my output, LT, gets assigned to, I'm not going to say equals because we need to use this assignment statement. Equals without this less than sign on it is a question. It is asking if two things are equal to each other. This, however, is assigning a value to less than. It is taking whatever I put on the right side and pushing it into LT, which is connected to my port up here of an output, and will make that value asserted. Excellent. So that equation, again, is Li or, let me check, not GI and not X and Y. So I type not GI and not X and not, and Y. Now, you'll notice that I have an error. If I mouse over it, this error will say something like syntax error near and. So something is unhappy. Basically, I need to specify a little more clearly for it what the order of operations are going to be. So I'm going to add some parentheses. So it's Li or this entire expression. So now it turns out that not is going to prioritize this GI, but we're going to go ahead and test that in a little while to make sure that I've designed something that makes sense. The next thing that I need to do is assign my GT output. It is greater than if GI or, and I'm going to use the same parentheses and remind us that it is not Li, X, and not Y. So not Li and X and not Y. I will point out at this moment in time, VHDL is not case sensitive. However, as a matter of making my code nice and readable, I tend to capitalize my logic functions. So ORs, NOTs, NANDs, etc. This allows it to be very quickly read. Hopefully, I have now successfully designed behavioral logic for a 1-bit comparator. I'm going to end this video here. In the next video, I'm going to create a test bench to test and see if my comparator works.